All right, we are looking at the quotient rule. Quotient rule says bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. And we're applying that to this first problem, and here's where we're at. Let's see. All right, job number 2 on this is now, after you get it all set up, is to distribute it out and combine like terms. So in this first piece, I've got 4x that's being multiplied by 3x. Now I have a 12x squared. A 4x times 1 is a 4x. In the back end of here, I have a 2x squared times 3. That's a 6x squared, so it's minus 6x squared. Now I will say a word of caution on this. If this had an extra term with it, remember you have to distribute that subtraction sign. So be careful of that subtraction sign. If you had more than one term after it, that negative gets attached to everybody. All right, then I'm over 3x squared, or 3x plus 1 squared. The squares on the outside. All right, combine like terms. Let's see what happens. 12x squared minus 6x squared is 6x squared plus 4x all over 3x plus 1 quantity squared. Now, you're at a place where you're like, well, should I factor? This kind of came up with the product rule when we were looking at product rule things. When do you stop? When do you factor? When do you not factor? Do you have to factor? Do you not have to factor? All that question is the same thing with this. So think about it in your head. If you were to take something out, you could take a 2 and an x out of this top. If I take a 2x out, that leaves me with 3x squared plus 2. Well, that's not going to help me any, right? It doesn't cancel anything out. So since it doesn't do any good for you, this is a great final answer. You're done. So you don't have to take it any further. So the question of do you take it further or not really depends on if it benefits the problem to simplify it more. And in this case, it doesn't. So that's what you got. All right, number 2. This one's a g prime of x. Looking for my derivative. I'm going to apply the same rule. Bottom, 2x, times the derivative of the top. Well, the derivative of 3 to e to the x is 3e to the x. E to the x's are sweet. Minus the top, 3e to the x, over the derivative of the bottom. The derivative of a 2x is just a 2, over the bottom squared. 2x squared. All right, let's see if we can simplify this a little bit. 2x times 3e to the x gives me a 6x e to the x. Minus, and over here, this is just a single term, 2 times 3e to the x is a 6e to the x. Over 2x squared. Well, 2x squared is really 4x squared. How come I didn't square out this whole one over here? Because it's a binomial, it's 2 terms, and it wasn't going to help me any in the problem. In this case, I got a little simplifying I can actually do in this one. So I actually did square that piece out. So if I look at these 2 terms on top, they both have a 6e to the x that I can factor out. That leaves me with an x minus 1 over 4x squared. And so the 6 and the 4 can be reduced. That gives me final best answer of 3e to the x times x minus 1 all over, if I divide by 2 on the bottom, a 2x squared. All right, questions so far? Anything? So here's what I want you to do. I want you to set up number 3. See if you can do what the quotient rule says, and then we'll see if we match. Just do the first part, and then we'll take it from there, because there's going to be a lot of, well, actually, there's not a whole lot of, the answer just falls into place. So see if you can do this. Apply the quotient rule. Did you get it? Do we match? You can't really pretty this one up much. There's not really a whole lot of simplifying to do on him. I guess you really could write the second term as the 4x in the front. That normally would be the case in front of the trig function, but really there's not any simplifying that goes on with this guy. Did anybody think to cancel out the 2x minus 5's top and bottom? I hope the answer is no, because it would have to come out of both of these terms. This term would have to have a 2x squared minus 5 as well in order for you to cancel it. So just because it's with the one term doesn't mean it's cancelable. All right. That's it, number 3. Number 4 changes things up. Are you ready? Number 4, you can absolutely use the quotient rule right off the bat with this. That is not a wrong move to go. So take your 2x squared times the derivative of the top 3, yada yada, take your way through it. But there's also, because this is a single denominator, a single term denominator, if I go back to number 3's denominator had 2 terms. It's a binomial. It's got 2 different terms in it, right? You got a 2x squared and a 5. This one has a single term. This trick only works if it's a single term denominator. And what you really are looking at is changing it and making it 3x over 2x squared plus 1 over 2x squared. Right? Just splitting the fraction apart and then simplifying that. So if I think about that, and I'm still working with my regular h of x. I'm not talking about derivatives yet. I can cancel an x, right? So I end up with 3 on top, 2 on the bottom, and an x on the bottom. Second fraction, I have 1 over 2x squared. That one I can't do anything else with. Now thinking about trying to apply the power rule to this, how would you write that? This first guy would be 3 over 2x to the negative 1. And the second guy would be 1/2 x to the negative 2. And if I can rewrite it that way, then that means I can just apply the power rule and I don't have to go through all the quotient rule to get there. So h prime of x, sometimes that's simpler than using the actual quotient rule. So let's take the derivative of this revised version of h of x. The negative 1 comes down in front. Negative 3/2 x to the next power is negative 2. This one, the negative 2 comes down in front. Negative 2 times 1/2 is 1. Take it to 1 less power, that's an x cubed. I'm sorry, x to the negative 3. So when I write the final answer without the negative exponents, like Mr. AP prefers, I get negative 3 over 2 with an x squared on the bottom and a 1 over x cubed for the second term. And that's the same answer I would have gotten had I used the quotient rule. Only works when you have a single term denominator. All right, now from tables. The table below shows 2 differentiable functions, f and g, as well as their derivatives when x equals 2, and they want you to figure out what h of x is. If h of x is this function, what's h prime of 2? So what I tend to do is I write these out first, just using your quotient rule. So h prime, what's it going to look like? H prime of x. We'll get to the 2 in a second. If I'm h prime of x, it's bottom times the derivative of the top minus top times derivative of the bottom over the bottom squared. That's all I'm writing, but I'm going to write it in terms of f's and g's. So the bottom is 3g of x, bottom, times the derivative of the top. Well, the derivative of the top will be an f prime of x, minus the top, f of x, times the derivative of the bottom. Well, the derivative of a 3gx, g of x, is 3g prime of x. The constant in front just stays in front. And all of that is over the denominator squared. 3 times g of x squared. So for safety measures, I write it out first. And now the second thing I want to do is put in the 2's. I know what the x value is. My x value is 2. I want to know what h prime of 2 is. So I have 3 times g of 2, f prime of 2, minus f of 2, times 3 times g prime of 2, all over 3 times g of 2 squared. Now, you may say, can you just jump from your function to this last piece? Absolutely. You don't have to go through the x's first. It's really because they told you what the value was that you're looking at. You're looking at 2. Because at this point now, you're going to then go to the chart and figure out and fill in all these numbers. Again, this is going to be a number answer because they want to know what's the derivative at 2. So you're going to have a number answer for this. You won't have x's in there like you did up above. All right, so let's fill in the values and see. There's, again, so many places for algebra mistakes, so be very careful. We saw that back in section 2.8 with the product rules, similar questions like this. All right, so I have 3 times g of 2. G of 2 is -1. Times f prime of 2. F prime of 2 is -2. Minus f of 2 is 4, and 3 times g prime of 2, g prime of 2 is 2. All of that is over 3 times g of 2, which is a -1, squared. All right, let's see if we can figure this out. I have 3 times -1 is -3. -3 times -2 is 6. On the back side here, I have 3 times 2 is 6. 6 times 4 is 24. So my numerator is 6 minus 24. And my denominator is 3 times -1, -3. -3 squared is 9. All right, well, 6 minus 24 gives me a -18 over 9. And I finally get an answer of -2. Okay with that guy? Number 6. This one, watch this weird negative sign in the front of this. They did this on one of the homework problems too. They just put this random negative sign there. So here's what I would do. I would take, remember, negative signs can, in this case, they put it out in front, but it can also be either attached to the numerator or the denominator. Now your denominator is a little bit messy, so I wouldn't attach it there. I would toss it on the top. So I would rewrite this before I started as negative g of x over 1 minus f of x. Attach that negative sign so that you actually have it in the problem rather than out in front. All right, we want to know what it is at 2. You can go directly to the 2 stage of this thing without going through the x's if you'd prefer. That's probably where I'm going to go. So the bottom is, if I'm finding r prime of 2, I'm ho-de-hi-ing, start on the bottom. 1 minus f of 2 times the derivative of the top. Well, the derivative of the top is going to be a negative g prime of 2 minus the top, negative g of 2, times the derivative of the bottom. Remember, the derivative of 1 is 0, so you don't have that, but you do have a negative f of x, so your derivative of that would be a negative f prime of x. In our case, our x is 2. All over the bottom, 1 minus f of 2 squared. So there's your setup. So take a minute and fill it in, and we'll see if we match on what our number answer is. This one comes out with a fractional answer rather than a whole number answer like number 5 did. So take a minute, fill in all your pieces. Let's see if we match it up. Watch your signs. Anybody else get what I got? Cool. Good. Okay, good. Do you see how many places you can make such little mistakes? Like one little mistake can throw the entire thing off. In fact, I didn't put a prime on this guy, so I was plugging in the wrong number when I did it. But yeah, I had to go back and fix. Lots of places. Why did I put the G first in the second term? Because this is the top times the derivative of the bottom. So this would be my top term, which is negative G of 2 in our case, times the derivative of the bottom, which was a negative F prime of 2. So the G in this is first in the second term. Because of that, it's the bottom times derivative of the top minus the top times derivative of the bottom over the bottom squared. So it's totally just following that quotient rule is why that guy came first. Yeah, she's Catherine, you're going back to this guy up here, this h prime of x thing. I mean, you can absolutely do that, but sometimes just remembering it from the words rather than the f's and the g's. This one's messed up because look at how the fraction is. In this one, it's the f on top and the g on the bottom, where the one that we just did was G on top and F on the bottom. I think that's why you're getting confused and mixing up your F's and G's in the midst. So if you think of it more in terms of the words, that it's the bottom times the derivative of the top minus top times derivative of the bottom over bottom squared, regardless of what they're calling them, F's or G's or H's or whatever, might be a safer route. But yeah, that one's messed up because it's opposite. The G's the top function and the F is the bottom function. All right, so that was it for the examples. We have a few problems that I chose, and I'll take requests for other ones as well from these guys. Number 5 was my first one that I chose. So if you grab number 5 on the practice problems. I thought number 5 was kind of interesting because, yeah, I'm all into finding the derivative via the quotient rule, right? It's a fraction. But this is one of those that you actually can simplify first because remember it's a single term denominator. So I can break it apart and make it 3x to the 4th over x, 2x squared over x, 3x to the 1/2 over x, and then just use the big old power rule we've always been using. So if I look at this one and simplify it first, I'm not changing anything yet. I'm not derivativing yet. I'm just going to make it so that I can use the power rule on it. All right, here goes. 3x to the 4th over x. X to the 4th over x to the 1st. Subtract the exponents. You're at 3x cubed. Minus 2x squared over x. 2 minus 1 is 1. This gives me a 2x. Now the hardest one is this last guy, right? He's a 3x to the 1/2. If I have 1/2 minus 1, 1/2 minus 1, I get a negative 1/2. Now I'm going to write it just like that, a negative 1/2. Oh, there's a 3 there. Hold on, let me put the 3 in. Now if I leave it like that, that makes me able to use the power rule on it pretty quickly. So that's what I'm going to do to find the derivative. F prime of x. Power rule, here it goes, 9x squared. You guys got really good at this after that quiz the other day. There were a whole bunch of these kind of things. The last one comes down, it's a plus 3/2. And it's going to be x to the, let's think about this, negative 1/2 minus 1 is negative 1 1/2, or negative 3/2. All right, Mr. AP, I'll write it one more time. Make it pretty for you. Plus 3 over 2. You can write it as a power, you can write it as a root. I'm going with the power. X on the bottom to the 3/2 power. All right, number 6 is the next one on my choice. Number 6. This one I can't simplify. Even though it has a singleton denominator, it's a cosine, so that's not quite the same thing. Can't use the power rule on that. So you're just going to have to write it out using the quotient rule the regular old way. So this one, my derivative, is the bottom cosine of x times the derivative of the top. Well, the derivative of a 2x to the 5th is a 10x to the 4th minus the top, 2x to the 5th, over the derivative of the bottom. Well, the derivative of cosine is negative sine. Make sure you have your card handy, right? The question on the chat is, for that last one, if this were written as a root, it would be the square root of x cubed. That's correct. Yeah, the square root. The denominator tells you the root, and the numerator tells you the exponent. So yes, that is true. All right, we got the numerator set up. Let's get to the denominator. That would be the cosine of x squared. Well, I can pretty that up just a little bit, because normally, like, I got signs here that I need to do. Also, be careful that you realize that that's a negative sign, not a subtraction sign. Sometimes they get kind of confusing as you're writing it out. Just be cautious. So 10x to the 4th cosine of x is my first term in the numerator. My second term is a negative negative, making it a plus. And then I have a 2x to the 5th sine of x. And that is all over a cosine of x squared. You could also say cosine squared x. Remember, you can write that the 2 different ways. But here's an answer that I want you to think about. I'm changing colors because I can. I want you to think about this. Is this an equivalent answer? 10x to the 4th secant of x plus 2x to the 5th tangent of x secant of x. My question for you is, would that be an equivalent answer? You know how a lot of these things have, there's different ways you might see it on a like a multiple choice list of choices for you. So here's my answer. This could be the book's answer. Are they right? It's going to take you, you're thinking about your trig stuff from back in the day. And of course, I'm not going to give it to you if it's going to be a wrong answer, right? The answer is, yeah, it's got to work. So let's talk about why. So if I have a cosine, like obviously you've got the 10x to the 4th, that's fine. Cosine over cosine squared. Well, you can cancel 1 for 1. So this cosine on top would cancel with one of them on the bottom, but you'd still have a cosine in the denominator, like a 1 over cosine. Well, 1 over cosine is your reciprocal relationship that's secant. So this works. This actually does become this piece. This one, if I have a sine over cosine is tangent, but I still am left with one more cosine in the denominator, just like it was in that first term. And if I have a denominator of cosine, 1 over cosine is secant. And so yeah, it's an equivalent form. So you got to remember that on a multiple choice question, Mr. AP could put it a couple different ways that are all equivalent. So all of those rules still apply from what you learned back in pre-calc, which is kind of interesting. Okay, so here's the next one I want to look at, number 7. 7. Why don't you try it and I try it and we'll see if we match. Number 7. Go for it. All right, did you get to this place? Do you have a hankering to factor something out to make it prettier? Right, I'm with you. Like, yeah, that's okay, Maddie. That's exactly. Take the 4e to the x out. Yeah, you're all on the same page. Like, this one makes you want to factor something out. Do you see the difference? So let's see what happens if we do. You're all thinking in the same. I'm seeing from my chat there that you're thinking the same thing. Let's see what happens. If I take that 4e to the x out, that's going to give me a sine of x minus cosine of x. Now, how about the bottom? There's a 4 down there. That makes me think that maybe I should square this thing and make it 16, right? 4 squared is 16. Sine of x squared, sine squared x, however you want to write that. Which makes me say then that my 4 and my 16 can cancel. And so I end up with an e to the x sine of x minus cosine of x on top. And on the bottom, I have a 4 sine squared x. And that, yeah, you're all, I'm watching your chats there, we're all saying the same thing. That's really the best answer for this one. Again, if it were a multiple choice question, there could be so many different equivalent answers that they would put in there that you could try to match it up to. But this one, it's funny because when you get to this place, we're all in that mental thinking of, ooh, there's too many things in common there. I probably should factor something out. And you do. All right. That is it for that page. If you flippy-do to the next page, we're going to try some of these ones with the tables. Number 12 was the choice that I had, and I chose that because if you look at some of the derivatives, they're a little bit tricky. All right, so number 12 is next on our list. Again, these are going to be number answers because we're filling it in from the table. You saw from the example that we did on the other page how that works. Actually, I'll take the harder one, B. We'll do together. But why don't you take a shot at A? You're going to do the ho-de-hi minus hi-de-ho over ho-ho, and then plug in the ones from the table and get a number answer. And I can tell you it's a fraction, and that's okay. So you try it and I try it. We'll see if we match. G prime of 1. All right, answer of 1/8. Are we good? All right, before we get into B, I'm going to change the way B looks so that I can better find the derivative. This whole dx over 2 thing at the end, on the top there, That's mean, because it's like making complex fractions in the midst of trying to find derivatives and quotient rules and everything else. So before I even start, I'm going to change the way this original one looks by calling it 2 minus 1/2 as a coefficient dx over, the bottom's fine, 6 minus h of x. So you see, if I pull that 1/2 out, it makes it a lot easier to try to do the derivative on this thing than in the fraction form. Okay, so I'm going to expand it, and again, this one's going to be a big one because I've got big pieces. I want to know what f prime of 1 is, so I take the bottom, 6 minus h of 1, times the derivative of the top. Well, derivative of 2 is 0. The derivative of a negative 1/2 d of x is a negative 1/2 d prime of 1 is our x, minus the top, 2 minus 1/2 d of 1, times the derivative of the bottom. Derivative of 6 is 0. So the derivative of a negative h of x is a negative h prime of x, with my x being a 1. All over the bottom squared. 6 minus h of 1 squared. All right, so we're going to plug in all of our values. If I do that, 6 minus h of 1 is 4. Negative 1/2 d prime of 1 is negative 2. If I do a minus, then I am a 2 minus 1/2 d of 1 is negative 4, and negative h prime of 1 is negative 3. All over. 6 minus h of 1 is 4 squared. Okay, so let's figure these pieces out. I have this negative 1/2 times a negative 2 gives me a positive 1. 6 minus 4 is 2. 2 times 1 is 2. Well, that makes that much prettier. If I come over here, and I've got half of 4 is 2. 2, and it's a positive, so I'm going to make plus. So this is going to be 2 plus 2 is 4. 4 times a negative 3, actually it's a negative, right? Yeah, because of the minus here. So it's going to be negative 12, so it makes it plus 12, over 2 squared, and that's 4. So if I have 2 plus 12, I've got 14. Fourths equals 7 halves. That's my final answer, 7 halves. Did you get it? All right, take a break and tell me something. Tell me your favorite color. Pink, that's a good one, Genevieve. Chloe, sage green. I like it. All right. I have to, my office obviously is getting redone at some point in time in the near future. I've got to figure out what color I want to paint it. I kind of like Chloe's sage green idea. Those calming kind of, you know, mellow colors. All right. We are ready for, we only have a couple left, kids. Number 13 is next on my list, and you'll see why. And then 16. And then if you have others, that might be, you know, I'll take requests as we go. But, so here's the next one, 13. They changed up the directions on us, and we want to know what's the equation of a tangent line at the given x value. So I'm looking at this, and there's a couple different things that come to mind with it. And the first thing is, if I think of my trig identities, what's sine over cosine equal to, right? Sine over cosine is tangent. So I could figure out if my function is tangent and I knew what the rule was for tangent derivatives, then I could answer this really quick. But the problem is, you don't learn the rule for tangent derivatives until next section, 210. Okay, so you'll be able to answer this more quickly in the next section. So for right now, we have to go with what we know, and we do know what derivatives are for sine and cosine. Okay, so you always want to approach these and see if you can simplify it into its most simplified part before you actually derivative it, where in this case it's not going to help you any. So we're going to hody high. Here it goes. Find the equation of the tangent line. You need the slope, you need the derivative. So I want to know what f prime of x is. Here comes the quotient rule. Cosine of x, bottom, times the derivative of the top. Well, that's a cosine of x. Minus the top, sine of x, times the derivative of the bottom. Derivative of cosine is negative sine, over the bottom squared. So really what I have, kind of interestingly enough, is cosine times cosine is cosine squared. A negative negative makes it plus. Sine squared all over cosine squared. Now my hope is that you should have bells going off in your head. Wait a minute, that looks like something I know. That's way simpler than what it's written as. Do you remember? Do you remember? This guy has that Pythagorean identity from back in the day, that cosine squared plus sine squared, I think they might have it the other way around, sine squared plus cosine squared, whatever. Addition is commutative, it doesn't matter the order of them. But sine squared plus cosine squared is a Pythagorean identity and it equals 1, yes! Yes, I see that in your chat. So this is actually 1 over the cosine squared x. Well, I need to think about then putting in, because remember I need to know what f prime of, what I'm really looking for is what's f prime of pi over 3. I'm looking for an actual slope so that I can come up with a tangent line equation. So that's going to be 1 over the cosine of pi over 3 squared. Now I'm going to change up the way I'm writing it, put the square on the outside. Remember, these are the same thing, just how they're written. This is going to be easier for me to algebra as I do it. So I've got to go to my unit circle, and that should be in your head. Is it in your head? And I have to think about what's the coordinate that goes with pi over 3. So if I go around my unit circle, are you all grabbing your chart? Hopefully you're just doing this out of your head. The coordinate is 1/2 the square root of 3 over 2. All right, well, for this particular problem, I'm looking at this coordinate, and I want to know the cosine from that coordinate. Cosine is the x value. So here's what I have. I have 1 over 1/2 squared. Well, think about that for a minute, right? That's going to be like 1 over 1/4, which is like 1 divided by 1/4, which is like, keep change flip, 1 times 4 over 1. 4, there's my slope. All of that to get to the slope of this thing. And you still need to figure out what the point is. Remember, you're trying to find the equation of the tangent line, you need a slope and a point. So all of that gave me the slope of the line. Now I'm going for the point. Well, they gave me the x value of pi over 3. I need to know what the corresponding y value would be for that. So you go back to the original function, sine of x over cosine of x, and you plug in what you got. You want sine of pi over 3 over cosine of pi over 3. That's going to give you your y coordinate. Well, that's totally going back to your coordinate for pi over 3, 1/2 square root of 3 over 2. Sine is the y value, square root of 3 over 2. And I'm going to just go horizontal right now. Divided by, this is my sine, the cosine is 1/2. If I had written it vertically, I'd have to turn it horizontal anyway. All right, so let's do that. Keep change flip. Square root of 3 over 2 times, flip, 2 over 1, Woohoo! My 2's cancel out and I get a square root of 3. So, there is my point. Now obviously once you have those two pieces, putting this tangent equation together, I'm going to come over here, putting the tangent line equation together is easy peasy lemon squeezy. So I've got y minus the square root of 3 equals a slope of 4 and x minus pi over 3. That is my tangent equation. Okie doke, one more. Here it is. Number 16 I thought was going to be one that would confuse you, because you know how Mr. AP likes to word his problems. I got all sorts of people. Okay. Dinging in there. Here we go. Let f and g be differentiable functions with the following properties. F of x is negative for all x. All your y values are below the x-axis, this means. Y values are less than 0 for every value of x. So it's all below the x-axis. And you've got a coordinate here that is 5, 2 for the g function. If f of x over g of x is your h of x function, and the derivative is f prime of x over g of x, then what's g of x? Now I know if you guys had come to this question doing it on the homework that you'd be like, what on earth is that asking me? And I'd be like, yeah, I got it. It's really, it's not a very pretty problem. But let's start with this. Let's start with what they're telling me here. And let me expand that using the quotient rule, right? H of x is f of x over g of x. Let me write that out and see what that actually looks like. So if I were to Hody high this thing, it would be this. Here's my h prime of x. You're going to start with the bottom, g of x, times the derivative of the top, f prime of x, minus the top, f of x, times the derivative of the bottom, g prime of x, over the bottom squared. So if I'm looking at this, it has, and this is where it gets complicated, so put your thinking caps on for a second. My final answer for h prime of x is that I've got f prime of x on top and a g of x on the bottom. So my question for you, let me change my color here, is here's my f prime of x, right? So this first term has to be somewhere in this problem. It doesn't disappear. But this guy over here, what happened to him? Now remember, I'm trying to get it here. I don't have a g prime of x. I don't have an f of x. I have an f prime of x. So this term, this second piece here, must zero out. It doesn't exist in the actual derivative for the h function. So this second term zeroes out. There is no f. It only has an f prime. It doesn't have a g prime in it. This is got to be gone. So now here's what you're left with. If that second term zeroed out, here's what you're left with. H prime of x equals the g of x times f prime of x over a g of x squared, right? Because minus 0 gets that whole other term knocked out. Now what do you notice about the g of x's, right? 1 on top and you got 2 on the bottom. They actually can simplify. So now you have an f prime of x. If I cancel one of the g's on the top with one of the ones on the bottom, I'm still left with 1 on the bottom. So there it is. You got your h prime of x to match up with what this is. And now think about what your options are. This g of x term has to be some kind of a constant. It can't be 0 because you can't have a 0 denominator, right? So it obviously can't be this guy. And there is nothing that they told you that allows you to have any kind of comparison with the f function. right? So all you know is that it has to be some kind of a constant and it can't be 0. So the answer to this guy is E. Would you have gotten that? Probably chances are no. That's a hard one. Yeah, I don't think so either. Like, if I were to be honest with you, I 100% agree with my chatters there. I would not have gotten that either without having really thought that through. It makes sense once you see it, but there's a whole lot of thinking that goes into that guy. He was mean. But occasionally, Mr. AP, he'll do that to you. Okay, do you have any other requests for where we're at? All right, got the idea with the quotient rule then. Here's your story. I'm going to go back to where we started. Wednesdays, I'll come back and talk about that in just a second. Due for Sunday, because we're going to go over them on Monday. So due for Sunday are these problems from section 2.9, 1 to 18, the ones we did not do. We are going to do section 210 on Monday, and we are working towards a test in the very near future. It could be Thursday, as early as Thursday. I will post our review sheet because I know some of you like to work ahead, so I'll make sure that gets posted for us quickly. As for Wednesdays, I know that they're no longer mandatory for you to be in class. You're only mandatory for Monday, Thursday, which is fine. I'm going to actually keep Wednesdays for maybe going over homework so that you can have optional dial in if you have questions. But I'll keep you informed as to how we really need to work as much as we can, since we're trying to get done a whole lot of material before the AP test. So I'm not going to say that Wednesdays are mandatory. They're not. They'll be optional, and I'll try to keep the material that we cover on Wednesdays to be stuff that you can choose to dial in or not choose to dial in. But we'll see how it all floats out. So that's the game plan, I think, at the moment for Wednesdays. Like for this week coming up, I might be taking questions from the review sheet so that you're ready for the test on Thursday. So if you have questions from the review sheet, dial in, and if you don't, then don't. So I believe, does that sound okay for a Wednesday plan? If you've got better ideas, let me know. But yeah, luckily Wednesday's 9, like 7:45 is a little rough. But for Wednesdays, at least it's a 9 o'clock kind of thing. So. Okay. All right. So you got what we're on to for the next thing on your. There should be a couple things on your docket. First thing is make sure that you get these 2.9 by Sunday. Keep your mastery check. Make sure you're working on those. And then I will post the review sheet that we're going to be working on for next week, getting ready for a test. I'm going to hope it's going to be Thursday. So we're going to tentatively say test Thursday. Okay. Yes, Maddie, that's what I'm thinking. Like, depending on how you feel about the material for Wednesdays, you can dial in or not. And then, so that's the game plan for the moment. All right. Have a great weekend, and I will see you again on Monday. But email me if you have questions, okay?